Hello everyone. For this particular lecture video, we'll be having a new topic titled gases. Let's start. These are the following lesson objectives. First is we need to define each gas laws. Second is use the gas laws to describe the relationships among pressure, volume, temperature, and amount of gas under certain conditions. And third is calculate certain gaseous conditions using the gas law equations. This will be the outline. You have here the four gas laws that we need to identify, define, and at the same time apply in calculation. Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. Now the following, or this slide, will just show you the units that we'll be using, or the units that we will be using for pressure. Now these are the commonly used units for gas pressure. You have here atmosphere, represented by atm. You have your millimeters mercury, torr, Pascal, and then pounds per square inch or PSI. Please do take note that these are some of the important conversion factors that you need to remember. 1 atm or 1 atmospheric pressure is equal to 760 millimeters mercury is also equal to 760 torr. 1 atmospheric pressure is equal to 101,325 pascals or 101.3 kilopascal. And then 1 atmosphere is equal to 14.7 pounds per square inch or PSI. Let's start with the gas laws proper. Boyle's law. In the 17th century, the Irish scientist Robert Boyle investigated the pressure-volume relationship of gases using experimental observations. Now, as the name suggests, or the name of the law suggests, this was discovered or devised by Robert Boyle. Now, what about Boyle's law? So let me write it to this one. So we have here Boyle's law. Now, what about Boyle's law? Now, your Boyle's law, according to the law, is a law that states that for a fixed amount of gas, represented by N, held at constant temperature, represented by T, the pressure, represented by P, of a gas is inversely proportional to its volume. So when we say inversely proportional, that simply means when your pressure, okay, the relationship of the pressure and volume are inversely proportional, meaning to say, when your volume is increased, your pressure is decreased. Or on the other hand, if your volume was decreased in terms of value, your pressure increases. So inversely proportional. So that is the meaning or the idea behind being inversely proportional. Now the formula for Boyle's law is given with the equation initial pressure multiplied by initial volume is equal to the final pressure multiplied by final volume. So this will be our main equation. P1 V1 is equal to P2 V2. Let us have an example for Boyle's law. Okay, so let me read the problem. A gas sample is observed to exert a pressure of 600 torr when confined to a 10.0 liter vessel at 27 degrees Celsius. What will be its pressure when the gas is transferred to an 8.00 liter vessel at the same temperature? So we follow the Gressa format. Okay, so the Gressa format simply means given, required, equation, solution, and answer. So let's start with given. So the given are initial pressure, 600 torr, initial volume, 10.0 liter, and then final volume, we have it here, 8.00 liter. Our required is pressure, so that means final pressure. And then the equation, we use the main equation for Boyle's law, P1 V1 is equal to P2 V2. Now since the one we require to solve for is P sub 2, let us derive an equation such that we have P sub 2. So divide both sides by final volume, divide both sides by V sub 2, cancel V sub 2 on the right side, we now have the equation P sub 2 is equal to P1 V1 all over V sub 2. Okay, at this point, we write our solution. Now with the solution, now since the units are appropriate and we can easily cancel them, your P sub 1 is 600 torr multiplied by 10.0 liters all over 8.00 liters. So cancel the unit liters, we have the unit torr. Now since we have unit torr is an appropriate unit for your pressure. Okay, so input that one in the calculator. We have this particular answer, 750 point torr. Now since our given are the following, 600 point, 10.0, 8.00, all of which have 3 significant figures. So since 3 significant figures for all given unit, the least sig fig must be 3 so that we can round off our final answer according to the significant figure. So this is already 3 significant figure, 750. So this is correct. Okay? Okay. Next one. Now at this point, let's talk about the next law. Now the next law is what we call the Charles law. This gas law was named after the French scientist Jacques Charles. Charles studied the relationship between the volume and the temperature of a gas. Charles' law states that the volume of a fixed amount of gas held at constant pressure is directly proportional to its absolute temperature. Take note that absolute temperature refers to the temperature in Kelvin and not in degrees Celsius. Alright, let me just reiterate what the definition or the slide would like to tell us. Now your Charles law, so let me write that one, Charles law, would like to tell us the relationship between volume and temperature. Since volume and temperature are directly proportional, that simply means when increase of temperature happen, your volume also increases. And on the other hand, when temperature decreases, your volume also decreases. So therefore, directly proportional. In terms of equation, the Charles law has an equation, V1 all over T1 is equal to V sub 2 all over T sub 2. So this will be our main equation for Charles law. Okay? And then, please do not forget the temperature, okay? Temperature in Charles law must be in the unit Kelvin. Okay? What does that mean? Say for example, you have here, you need to convert the unit to Kelvin. The unit Kelvin is K. So, say for example, the given temperature was degrees Celsius. So degrees Celsius, whatever the value is, just simply add 273. Then you get the value for the unit Kelvin. Now say for example, you want to convert Kelvin back to degrees Celsius. So you just need to do Kelvin minus 273. So let me reiterate, ganito po. Kung Kelvin po ang dapat na final unit, kung ano po yung binigay na degrees Celsius na value, mag-add lang po ng 273. Ngayon naman, kung Kelvin ang binigay at ang hinihinging unit ay degrees Celsius, mag-subtract lang po ng 273. Okay? So that's the idea. Let me provide an example. So example here, let me read it. A gas held at a constant pressure of 750 millimeters mercury occupies a volume of 12.0 liters at 25 degrees Celsius. At what temperature in degrees Celsius will the gas occupy a volume of 15.0 liters? Okay, so following the Charles law and also the Gressa format, your given is initial volume, that is 12.0 liter, initial temperature, that is 25 degrees Celsius, and then your final temperature, according to the problem, is the one we are required to have. At what temperature? Okay, so the one we require. Then another given here is you have your final volume, 15.0 liter. Okay, now we have here, or we need to write the equation. Now the equation is V1 all over T sub 1 is equal to V sub 2 all over T sub 2. To make things easier, let us create an equation such that we can solve for T sub 2. So the first step is that cross multiply. Okay, so cross multiply, we have V1 multiplied by T sub 2 is equal to V sub 2 times T sub 1. And then, since we need to create an equation for T sub 2, divide both sides by V sub 1. Okay, so let me just scroll down. So divide both sides by v sub 1. We now have the equation t sub 2 is equal to v sub 2 t sub 1 all over v sub 1. So it's that simple. Okay, so now we proceed with solution. So t sub 2 is equal to the following. Now, since we're talking about absolute temperature, your degree Celsius here must be converted into Kelvin. So convert degree Celsius to Kelvin by simply adding 273. So 25, so let us look at the calculator. 25 plus 273, we have 298 Kelvin. So this will be our T sub 1. So let us write that one, 15.0 liters V sub 2 multiplied by 298 Kelvin all over 12.0 liters. So liters will be cancelled. We now have the unit Kelvin. Okay, so input in the calculator, 15.0 multiplied by 298 all over 12.0. You have this answer. Okay, but then again, what is the least significant figure among the given? The least significant figure among the values that you've divided, so this is 3 significant figure, 298 is 3 significant figure, 12.0 is 3 significant figure. So the least significant figure among the given is 3. So therefore, your final answer, 372.5, should be rounded off into 3 sig fig. So you have 373. Okay? However, looking back at the question, the one required is degree Celsius. So meaning to say, your T sub 2 should not be in Kelvin. So 373 must be further converted by simply subtracting 273 to have degree Celsius. Okay, so 373 minus 273. We have 100. So the final answer is 100 degrees Celsius. So looking at the PowerPoint, I have the same solution, plus I have the same value for Kelvin, and then the answer that we need in degrees Celsius being 100. Okay, so hopefully that is clear. Okay, okay. Moving on, the next law that I will be discussing is Gay-Lussac's law. The Gay-Lussac's law was named after Joseph Louis Gay-Lussac. This law describes the pressure-temperature relationship. The Gay-Lussac's law states that the pressure of a fixed amount of gas at constant volume is directly proportional to its absolute temperature. So let me write that one. We have your Gay-Lussac's law. So let me just reiterate what the law would like to say. That means when your pressure and temperature are adjusting, say for example, pressure is increased, temperature also increases. Or when pressure is decreasing, your temperature is also decreasing. Because according to the law, pressure, okay, and temperature, absolute temperature, are directly proportional. So both factors will increase, or if one factor increases, the other will increase as well. If one of the factors decreases, the other factor also decreases. Okay? In terms of equation, we have T sub 1 all over T sub 1 is equal to P sub 2 all over T sub 2. And then again, we're talking about absolute temperature. Therefore, our temperature must be in the unit Kelvin. Okay, so unit Kelvin always our temperature. So every time we will be doing the solution, make sure before you write the solution or do the solution part, okay, make sure that whatever the temperature unit are, convert it into Kelvin or make sure they are in Kelvin unit. Okay? Okay. Example. A 1.0 liter sample of nitrogen gas inside metal container at 20.0 degrees Celsius is heated until its temperature is 95.0 degrees Celsius. The pressure inside the container at 20.0 degrees Celsius was at 3.00 atmosphere. What is the pressure of the nitrogen gas after its temperature is increased to 95.0 degrees Celsius? So again, write the given. So my given are, so say for example, so the given here are, you have here pressure 1, My first pressure or initial pressure is 3.00 atmosphere. My initial temperature is 20.0 degrees Celsius. And then the final temperature is 95.0 degrees Celsius. So the one we are required to solve for is pressure number 2. Because according to the question, what is the pressure? Okay, so pressure number 2. The equation for this particular problem will be having T sub 1, okay, all over T sub 1 is equal to P sub 2 all over P sub 2. Okay. Now the first step is we do the cross multiplication to make things much simpler. We have P1 multiplied by T sub 2 is equal to P sub 2 multiplied by T sub 1. And now since P sub 2 is the one we require to solve for, divide both sides by T sub 1 such that we have an equation for P sub 2 being P sub 2 is equal to initial pressure times final temperature all over initial temperature. Okay, it's that simple. Okay, so from the initial equation, P1 all over T1 is equal to P2 over T2, we created an equation. Or rather, we constructed an equation from it. So for the solution part, okay, take note again that our temperature should be in the unit Kelvin. So that is why our degrees Celsius here must be added with 273. Remember that one. Our temperature should be in Kelvin. So looking at the calculator, 20.0 plus 273, we have 293 Kelvin. And then 95.0 plus 273, we have 368 Kelvin. So before you proceed, make sure that the temperatures are converted into Kelvin. So using this equation, so P sub 1 is already given 3.00 atmosphere multiplied by T sub 2, that is 368 Kelvin, all over T sub 1, 293 Kelvin. Kelvin will be cancelled. You have the unit atmosphere, which is appropriate for the factor pressure, which is the one we are required to solve for. So input in the calculator, we have this particular answer. So looking at your factors, this is 3 significant figure, 3 significant figure as well, and then 3 significant figure. So the least significant figure among the given is 3. So we need to round off our final answer according to 3 sig fig. So the answer is 3.77 atmosphere. And let's check if this is correct. All right, so I have the same solution, and then the answer is 3.77 atmosphere as well. Okay, so I hope you understand how this is applied or solved for. Okay, okay. Next, let's talk about Avogadro's law. Let me read the slide. This gas law was named after the Italian scientist Amedeo Avogadro. Avogadro's law describes the relationship between the volume of the gas and the amount of gas molecules in moles. Simply, the Avogadro's law states that for a gas held at constant pressure and temperature, the volume of the gas, or V, is directly proportional to the number of moles of the gas present, or in. So Avogadro's law states that, let me write that one. Avogadro's law simply gives us an idea that when the volume, okay, and number of moles n, they have direct proportional relationship, directly proportional. That means when your volume increases, number of moles also increases, and therefore, when volume decreases, number of moles also decreases, directly proportional. Okay, so you have the relationship or the equation, initial volume all over initial number of mole is equal to final volume all over final number of mole. Okay, so hopefully that is easily understood. So remember, for Avogadro's law, when we mention under STP or under standard temperature and pressure condition, the volume, okay, for an ideal gas is that 1 mole of an ideal gas will occupy, okay, 22.4 liters. So let me repeat, for Avogadro's law, when it is mentioned that the conditions are under STP or standard temperature and pressure, the volume for 1 mole will be 22.4 liters. So then again, ang gusto lang po sabihin nun ay kapag binanggit po sa problem na at STP or standard temperature pressure ang condition, for example, walang binigay na volume, walang given na volume, okay? Pero binanggit na STP, under STP daw yung condition. Kahit na walang given na volume at binanggit na under STP, automatic ang volume mo ay 22.4 liter. So what if walang given na number of mole, pero binanggit na under STP? Kapag ganun po ang nangyari, ang magiging N mo ay 1 mole. So ganun po, kapag kulang or hindi nabanggit ang given na volume or number of mole, pero sinabi na under STP, automatic your volume will be 22.4 and then your number of mole will be automatically 1 mole kapag under STP. Okay? Okay. Let us have an example. So let me read the problem. 2.50 liters of a gas is known to contain 0.765 moles of gas. If the amount of gas is increased to 1.25 mole, what will be the new volume of the gas if its pressure and temperature are held constant? So let me write the given. Your given are initial volume, 2.50 liters, initial number of mole, 0.765 moles, and then final number of moles, 1.25. Now, what about the required? Now, according to the problem, the one that we are required to solve for, okay, is the new volume. So, therefore, new volume, that is V sub 2. Okay? So, we need to solve for V sub 2. How about the equation? So, we know that V sub 1 all over N sub 1 is equal to V sub 2 all over N sub 2. So to create a much more simpler equation for V sub 2, first thing is that we cross multiply. Now we have V1 and 2 is equal to V2 and 1. Then we need to solve for V sub 2. So create an equation for V sub 2 by simply dividing both sides by N sub 1. Now we have for solution the equation V sub 2 is equal to V1 and 2 all over N sub 1. So all factors are already appropriate, so we can simply substitute all given quantities. So V sub 1 will be 2.50 liters multiplied by 1.25 mole all over 0.765 moles. So moles will be cancelled. You have the liter unit, which is appropriate for volume. So input in the calculator, 2.50 multiplied by 1.25 all over 0.765, we have this answer. So look at the least significant figure among the factors. This is 3 significant figure, this is 3 significant figure, and this is 3 significant figure. So our final answer should be rounded off into 3 sig fig as well, 4.08. This is our final answer. So let us check. Same solution with that of the PowerPoint, and then same answer, 4.08. Okay? Okay. I hope everyone learned a thing or two in this particular topic about gas laws, discussing Boyle's law, Charles' law, Gay-Lussac's law, and as well as Avogadro's law. Okay? I hope, again, you learned a thing or two. Thank you, and have a great day.